Hello guys, how are you today? So today I'll be explaining the interactions in compounds, chapter 6 organic chemistry and the periodic table from 6.1 till 6.3. So let us get started. This is for AS chemistry. If you don't take AS chemistry, then don't worry, this video is not for the non-AS chemistry students. So let's start with the first section, which is section 6.1, group 2 elements. An element X lies below an element Y in group 2 in the periodic table, right? So group 2 in the periodic table, they asked us, can you give a definite comparison of their metallic radii? First of all, we know that they're in the same group and we're going down a group. What you need to know is that as you go down a group, the metallic or atomic radius will increase. So what can we say in part A? We can say the metallic radius of X, because it's below Y, so it's like Y then X. The metallic radius of X is greater than the metallic radius of Y, because it has what it has, more occupied principal shells. For example, take magnesium and calcium as two examples. Calcium is going to be X, magnesium is going to be Y. The electronic configuration of magnesium is 1s2, 2s2, 2p6, 3s2. For calcium, it's 1s2. Actually, let me put it a bit higher. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So as you can see, what do they have? They have greater energy level. First of all, calcium has a greater energy level than magnesium, and it has a greater shielding effect than magnesium, because if you draw this, it's going to be neon 3s2 and this one is going to be argon 4s2. So because it has a greater shielding effect and a greater energy level, we know that calcium will have a greater metallic or atomic radius, which is the same reason for X having a greater metallic radius. Part B, can you give a definite comparison of their melting points? Well, actually in group 2, no, we cannot give a definite comparison because usually as we go down the group, the melting point decreases, right? But there is a small break in between, in group 2 of course, in between the two metals which we chose, which are magnesium and calcium, where instead of decreasing, it increases. So magnesium is going to be what? Less than calcium. So the melting point of magnesium is less than the melting point of calcium. Okay, so this is why we cannot give a definite comparison of their melting points. Now, last but not least, can you give a definite comparison of their densities? No. Again, why? Because as we go from beryllium to calcium, instead of from beryllium to calcium, it decreases. Then from calcium onwards, so from calcium until, until radium or barium, from calcium until barium, what happens? It increases instead. So this is why we cannot give a definite comparison of their densities. Alright, that's perfect. Now we move on to question number 2. What does it say in question number 2? It says magnesium, Mg, is a metal of group 2 of the periodic table that tends to form ionic compounds. Magnesium reacts very slowly with cold water but vigorously with steam. Right, the chemical equation of the reaction between magnesium and cold water. Remember, magnesium reacts with cold water and with steam. The equation with cold water is what? Is Mg solid, reacts with 2H2O liquid, in order for us to form what? In order for us to form MgOH2, which is aqueous, in addition to what? In addition to hydrogen gas. However, when it reacts with steam, it will not form MgOH2, it will form magnesium oxide. So it's going to be magnesium solid plus H2O gas will give us magnesium oxide solid in addition to H2 gas. Alright, so these you guys should have them known and memorized by heart. Now we move on to part B. Give the chemical equation for the reaction of magnesium Mg solid with the following species. First of all, magnesium reaction with hydrochloric acid. Very, very, very important. Magnesium solid will react with hydrochloric acid, which is aqueous, in order to give us what? First of all, magnesium is a metal, hydrochloric acid is an acid. So metal plus acid usually give us what? Usually give us salt plus hydrogen. Okay? So metal plus acid give us salt plus hydrogen. So the salt in this scenario is MgCl2 aqueous. You guys should know how to get it. In addition to hydrogen gas. Now, it's not balanced. To balance it, you just need to put a 2 over here. Perfect. Now, same thing with H2SO4. It's gonna be Mg solid plus H2SO4, where Mg is a metal, H2SO4 is an acid, right? So what will it give me? It will give me metal plus acid will give me salt plus hydrogen gas. So it's gonna give me the salt, which is MgSO4, which is also aqueous, in addition to what? In addition to hydrogen gas. Okay, perfect. That's it for part II. Now magnesium reaction with oxygen. So magnesium solid reacts with O2 gas to form magnesium oxide solid. Now this is not balanced. How do you balance it? Very simply, you put a 2 over here and a 2 over here. We move on to part 3. Give the shorthand electronic configuration of the calcium atom. We gave it before. That's going to be argon 4s2. Calcium reacts with liquid water to produce a hydroxide. Is calcium oxidized or reduced during this reaction? First of all, let us write down the reaction. Calcium, solid, reacts with water, which is liquid, H2O, liquid, to produce what? A hydroxide, which is CaOH2, aqueous, in addition to hydrogen gas. Now, of course, this is not balanced. You balance it by putting a 2 over here. So now, how can we find out whether it's oxidized or reduced? First of all, we need to know the definition of oxidation and reduction. Oxidation is loss of electrons. Reduction is gain of electrons. So this is what oil rig means, that oxidation is loss of electrons, reduction is gain of electrons. So let us see. First of all, calcium has 0 electrons over here. Here, hydrogen has 2 plus, oxygen has 2 minus. And of course, these are multiplied by 2. So just keep in mind that it's multiplied by 2. Then, calcium over here, it's going to be 2 plus. The oxidation number of calcium is 2 plus. Actually, if you don't know how to get it, we're going to call it X. X plus oxygen. We know that oxygen is minus 2, but we'll multiply it all by 2 because it's multiplied by 2. And then hydrogen is what? Is plus 1. Now, how do we find X? We just need to solve it equal to the charge, which is 0. So X plus minus 4 plus 2 is equal to 0. X minus 2 is equal to 0. X is then equal to 2. So we can erase all of this. And we can say that for calcium, it's going to be plus 2. Then for hydrogen over here, it is 0. So look what happened. To calcium, it was 0 oxidation number. Then it became how much? It became plus 2. So what happened? It lost electrons because it became more positive. So when it loses electrons, that means it undergoes oxidation. Perfect. Part CI gives a color that would compound imparts on a flame. So basically, I think they're asking for the color of calcium flame. It is brick red. Okay. Compare the reactivity of magnesium to that of calcium. We should know that as we go down group 2, okay, reactivity increases. So you can say it like that. You can say it like, as we go down group 2, reactivity increases. If you want to know why, because we said as we go down the group, the metallic radius increases. As the metallic radius increases, that means the valence electrons are farther from the nucleus. When they are farther from the nucleus, that means it's what? It's easy. Nucleus. That means it's what? It's easier to remove them. So we'll require less ionization energy. When we require a less ionization energy, then we can say that what? Then we can say that they are reactive. They're more reactive than the other element. Okay, perfect. That's question number 3. Just like that, we finished what? We finished 6.1. Let's move on to 6.2. What does it say in 6.2? Section 6.2, oxides and hydroxides of group 2 elements. Strontium oxide, SRO, reacts vigorously with water. Predict the pH of the solution resulting from the reaction between strontium oxide and water. First of all, strontium oxide is what? Is a metal oxide, and usually metal oxides are basic, meaning they can react with acids. Okay, so metal oxides are basic, they can react with acids. If they're basic, then that means their pH has to be greater than 7. Part B, give the chemical equation including the state symbols for the reaction. First of all, it's going to be what? It's going to be strontium oxide, which is a solid, in addition to H2O, which is a liquid, and it will give us what? It will give us strontium hydroxide, which is what? Which is an aqueous as well. We move on to part C. What does it say in part C? Strontium hydroxide reacts with hydrochloric acid. So now we have an even more base. Will react with what? Will react with an acid. When a base reacts with an acid, we undergo something called what? We undergo something called neutralization. So this is a neutralization reaction. So this reaction is a neutralization reaction. Give the chemical equation, including the state symbols for the reaction. So basically, for this part over here, it's gonna be SrOH2 aqueous reacts with 2-hydrochloric acid aqueous in order to give us SrCl2 aqueous. And we don't forget the water, H2O to H2O liquid. How did I know what to put? First of all, I put the base in addition to the acid, and then it will give me what? It will give me a salt and water. So if you remember this, you'll be just fine. You just need to remember that base plus acid gives me salt and water, and this is neutralization. Part III, write the net ionic equation for the reaction. We basically need to just like take the ions that were used. Very simply, in this scenario, it's gonna be what? It's gonna, aslan it was what? SrOH2 aqueous reacts with 2HCl aqueous in order to give us SrCl2 aqueous in addition to 2H2O liquid. So look what happened. We have Sr reacts with Cl2, okay, to form SrCl2. However, because it created an aqueous compound, we will not use it. So we cross out Sr, we cross out Cl, and we cross out SrCl2 because it made an aqueous compound. If it makes an aqueous compound, we're not going to use it. So we're left with two ions, which are OH minus and H plus. So H minus plus H plus will give us what? Will give us H2O, which is what? Which is a liquid, very simply. Part D, calcium hydroxide. Calcium hydroxide, CaOH2, is a hydroxide of group 2. Compare the solubility of CaOH2 to that of SrO2. What you need to know is that as we go down the group, the solubility of hydroxide, which is the OH2 hydroxides, increases. So as we go down the group, the solubility of hydroxides increases. That means as we go down the group, the pH is going to be more and more and more greater than 7. Because hydroxides are being more soluble in water, and it will release more hydroxides in the water, which will make it more basic, right? So what can we say in this scenario? We can say that the solubility of SrOH2 is greater than the solubility of CaOH2. We move on to part D, double I. Compare the relative pH of CaOH2 and SrOH2. What did I say before? I said that as we go down the group, solubility increases for hydroxides. So what does this mean? This means there's going to be a greater pH because more hydroxides are being released. Perfect. Now we move on to question number 5. Okay, question number 5. A mass of 0.438 grams, okay, of a group 2 metal M burns in excess oxygen to produce metal oxide. So what is the reaction? Metal, solid, reacts with O2, gas, to give us metal oxide solid, because we said they are in group 2. So to balance it, you just need to put a 2 over here. Perfect. Now, what did they tell us? They told us that the oxide, the metal oxide solid, dissolves in water. So we add it in water, right? To give a hydroxide solution, to give us only what? To give us metal hydroxide, MOH2, which is what? Which is aqueous. And what did they tell us? They told us it requires 10 centimeter cubed. Of course, always change it to decimeter cubed. So that's going to be 10 times 10 to the power of minus 3. And 1 mole per decimeter cubed. This is the concentration. So volume and concentration. So they told us to write the equation necessary for the 3 reactions described above. We already did that in part A when we were reading. Now part B, do the necessary calculations to identify metal M. What is metal M? They told us 0.438. First of all, how can we identify metal M? We can always identify a metal by finding its molar mass and then looking in the periodic table and finding it. So let us find the molar mass. We have the mass, right? So what equation relates the mass and the molar mass? It's very simply mass over molar mass equals number of moles N. Now what can we also deduce? We can find N by another method, which is N is equal to C times V. Perfect. We have concentration and we have a volume, so we will be able to solve it. But how will we be able to solve it? Very simply. Oh, actually, I forgot an important part. Oh, yeah. It's 10 centimeter cubed of 1 mole per decimeter cubed HCl to completely react. That means we'll take the metal hydroxide MOH2 aqueous. It will react with hydrochloric acid to give us what? To give us MCl2, metal chloride, and H2O, liquid. To balance it, you just put a 2 here and a 2 here. So metal hydroxide aqueous plus 2HCl aqueous will give us metal chloride, which is the salt aqueous, and 2H2O liquid. So now what will we do? Using the two equations, mass over molar mass, number of moles, and number of moles is concentration times volume, we'll be able to find what? We will be able to find the mass number of this. So let us start. First of all, they gave us a hint by telling us that the volume is 10 centimeter cubed and the concentration is 1 mole per decimeter cubed. So that means the number of moles of HCl over the coefficient. What's the coefficient? The coefficient is 2. Is equal to, first of all, how do we find the number of mole of HCl? It's going to be the concentration, which is 1, times the volume, which is 10 times 10 to the power of minus 3, divided by 2. This is equal to what? It's equal to the number of moles of metal hydroxide, so NMOH2, okay, over the coefficient, which is 1. Now, you can find the number of moles of metal hydroxide by doing what? By doing crisscross. So 2 number of mole metal hydroxide. Actually, no need for the crisscross. You can just like solve it directly. So we will get that the number of moles of metal OH2 is equal to what? Is equal to 5 times 10 to the power of minus 3 mole. Perfect. Now that we have this, we have the number of moles of metal hydroxide over the coefficient 1. We will make it equal now to what? We will make it equal to metal oxide. Are you seeing what we're doing over here? We're taking each one and we're linking it to something that's in the previous equation. So this one, I will link it with this because this is in the previous equation. So number of moles of metal hydroxide over the coefficient is equal to number of moles of metal oxide over the coefficient, which is 1, is equal to what? Is equal to 5 times 10 to the power of minus 3 mole. That means number of mole of metal oxide is how much? Is 5 times 10 to the power of minus 3. Now the final thing we're going to do is we're going to relate this and this. So the number of moles of metal oxide over coefficient, which is 1, is equal to the number of moles of metal over the coefficient, which is 2. So that means you substitute this by 5 times 10 to the power of minus 3. Oh, my bad, by the way, I did a balancing mistake. There's supposed to be a 2 over here. And you put it over 2 is equal to the number of moles of the metal over the coefficient. Sorry, my bad, I forgot to put a 2 over here. So now it's going to be what? It's going to be the number of moles of metal oxide, which is 5 times 10 to the power of minus 3, over the coefficient, which is 2, is equal to the number of moles of metal over 2. So you can remove this and you will get very simply that the number of moles of metal is what? Is 5 times 10 to the power of minus 3. Now what did we find? We found the number of moles of the metal, 5 times 10 to the power of minus 3. We have the mass. We need to find the molar mass. So that means molar mass is equal to the mass over number of moles. So it's going to be 0.438 divided by 5 times 10 to the power of minus 3, which is 87.6 grams per mole. And if you look in the periodic table, that's going to be what? That's going to be strontium. So our metal is strontium. Perfect. Now we move on to 6.3. 6.3 has like from question 6 to 11, like 5 questions. but they're long and require a bit of concentration, so I'll try my best to finish them. So let us start. The carbonates and nitrates of group 2 elements undergo thermal decomposition. Give the following chemical equation for the thermal decomposition of barium carbonate. Barium carbonate, BaCO3 solid, is gonna give me what? A decomposition. So it's gonna decompose. Carbonate will decompose into carbon dioxide and metal oxide. So metal carbonate solid will decompose into metal oxide and carbon dioxide. So it will decompose into barium oxide and what? And carbon dioxide. Don't forget that here this is solid and here this is gas. Perfect. Now calcium nitrate, CaNO3 2. Any metal of group 2, NO3 2, when it decomposes, it will give us metal oxide, okay, nitrogen dioxide, and what? And oxygen gas. So this is gas, this is gas, this is a solid, and this is what? This is also a solid. But now, it's a not balanced equation. How do we balance it? Very simply by putting a 2 over here, a 2 over here, and a 4 over here. That means if we were to do the decomposition of calcium nitrate, it would be 2 calcium nitrate decomposes into 2 calcium oxide solid, in addition to 4 nitrogen dioxide gas, in addition to O2 gas. My bad. O2 gas. Okay, so that is it for question number 6, part A. Let's move on to part B. Do you expect the decomposition of strontium carbonate to happen at a higher or lower or equal temperature to that of barium carbonate, and give a reason? So we're dealing with strontium and barium. So barium is downer in the group than strontium, and we know as we go down the group, thermal stability what? Decreases, right? Or sorry, no. Thermal stability increases as we go down a group. So what does this mean? This means that the more we go down the group, the more temperature we need in order for us to do what? For us to decompose. That means strontium will decompose at a lower temperature than that of barium, because as we go down the groups, thermal stability increases. Now we'll move on to question number 7. Under certain conditions, 0.01 mole of anhydrous magnesium nitrate is completely thermally decomposed to give 625 centimeter cubed of gas. Another experiment is done under the same conditions, in which 0.01 mole of anhydrous magnesium carbonate is completely thermally decomposed. So let us circle our given. Our first given is 0.01 mole of anhydrous magnesium nitrate is completely thermally decomposed to give 625 centimeter cubed. So this is what? This is our volume. So 625 times 10 to the power of minus 3 decimeter cubed of volume. Another experiment is done under the complete same condition, which give us what? 0.01 mole of magnesium carbonate is completely thermally decomposed. What is the total volume of gaseous products produced by the decomposition of 0.01 mole of magnesium carbonate? Very simply, we need to find out what is the relation that they did. So how can we find out the relation? Very simply, we'll write the two equations. First equation is 2 magnesium nitrate solid will decompose to give us 2 magnesium oxide, in addition to 4 nitrogen dioxide, in addition to what? In addition to oxygen gas. Now they told us that the total gas released, which is gonna be what? Which is gonna be the total gas, which is 1 plus 4, which is in total 5 moles of gas, has a volume of what? Has a volume of 625 times 10 to the power of minus 3. So 5 moles has a volume of 625 times 10 to the power of minus 3, right? So this is the first equation we have. Then the second equation that we have is what? Is magnesium carbonate, MgCO3, right? Solid will decompose to give us what? Will decompose to give us magnesium oxide, which is a solid, in addition to carbon dioxide, which is a gas. Now the total number of mole of the gas here is what? Is 1 mole. But before we continue, we'll look at the moles of the nitrate and the carbonate. It's 2 here and it's 1 here. That means the actual ratios of the gases are 5 divided by 2. 5 divided by 2, which is 2.5, and 1 divided by 1, which is what? Which is 1. So you do this coefficient divided by this, and this divided by this. That means for nitrate over carbonate, okay, it will be a ratio of 2.5 over 1. Alright, now what can we do with this? We can put the volume that we found from the nitrate. What's the volume of the nitrate? It was 625 decimeter cubed. Sorry, 625 times 10 to the power of minus 3 decimeter cubed divided by the volume that we need to find, or the volume of the carbonate. So now you just do crisscross and you're supposed to get an answer of what? So then after you solve it, you're going to get that volume of CO3 is equal to what? Volume of CO3 of, it's equal to what? It's equal to 0.250 decimeter cubed, which is 250 centimeter cubed. So this is the easiest way to do it. Let's move on to question number 8. In question number 8, what does it say? It says 5.76 grams, this is mass, of a hydrate of group 2 nitrate, which is this, is heated until all the water evaporates to produce 4 grams. So this is the mass of the total compound. So this is the mass of this. And 4 grams of what? 4 grams of nitrate. They told us when 4 grams of the described anhydrous nitrate decomposes, 2.24 grams of a brown gas is produced. That means when 4 grams of XNO32 decomposes, a brown gas is produced. Right? What did we say? We said when a metal nitrate decomposes, first of all, it's going to be 2 metal nitrate will decompose to give us 2 metal oxide in addition to 4 nitrogen dioxide in addition to oxygen gas. Now, the brown metal that they are talking about in this scenario, the brown gas that they're talking about in this scenario is the nitrogen dioxide gas. So now we need to base off our whole equation on the nitrogen dioxide gas. So it's gonna be 2XNO32 will give us 2 XO solid in addition to 4 NO2 gas in addition to oxygen gas. Okay, let me just erase these. Now, what do we need to do in this scenario? In this scenario, we need to relate this to find out what is X and this. So they told us it will produce 2.24 grams of brown gas. Okay, so we have the mass of nitrogen dioxide. So what can we do in this scenario? We can take the number of moles of XNO32 and we put it over the coefficient, which is 2. We know it's equal to the number of moles of NO2 gas divided by what? Divided by the coefficient, which is 4. So how do we find the number of moles of NO2? It's gonna be mass 2.24 divided by the molar mass, which is 46. 2.24 divided by 46, that's gonna be 0.049. So 0.049 divided by 4, how much will that give us as an answer? That will give us as an answer approximately 0.01225 moles. So the ratio of nitrogen dioxide gas is what? Is 0.01225 moles. Okay, so how do we find the number of moles of X? We need to do a cross multiplication. So when we do a cross multiplication, we will get number of mole of XNO32 is equal to what? Is equal to 0.024 approximately moles. Perfect. Now, what can we do with this? We have the mass of this, right? It's given to us as 4 grams, right? So mass is equal to 4 grams. We also have N, the number of moles. So how can we use the mass and N in order for us to find the molar mass of X? Very simply, we will say mass over molar mass is equal to N. So molar mass is equal to M over N. The mass in this scenario is 4. N in the scenario, we have it to be 0.0244 or just 0.024. You put it on the calculator, what will you get as an answer? 4 over 0.024. We will get 166 grams to be our answer. These are actually grams per mole. This is the molar mass. Now this is the molar mass entirely of what? The molar mass entirely of XNO32. So this is equal to XNO32. What about X? All of what we're solving is for us to be able to find what? For us to be able to find X. So what we did was we found the molar mass of X, NO32. Now let's find the molar mass of X. Molar mass of X is equal to the molar mass of X NO32 minus the molar mass of NO32. So very simply, let's do that. It's gonna be X is equal to 166 minus what? Minus NO32, that's gonna be 14 plus 16 times 3, all of it times 2, that's gonna be 124. So 166 minus 124, this will give us an answer of 42. So 42, or anything near 42, we will look to the periodic table, we'll see the nearest possible answer. In our scenario, the nearest possible answer is what? Is calcium. So that means the metal is calcium. What's the value of N? Actually, we found the value of N. Or no, actually, we did not find the value of N. Let us find the value of N. We know that it's what here? Instead of X, it's CaNO32 plus NH2O. So how do we find the value of N? Actually, very, very important question. Look how I would do it personally. Personally, I would take the mass of CaNO32, which is 4. I would divide it by the molar mass of CaNO32. So that's going to be 40 plus, open brackets, 14 plus 16 times 3, and all of it multiplied by 2, you're supposed to get 164, so 4 over 164, that's gonna give us what? 0.0244 moles, okay? Now, what do we do for water? We found us the number of moles of what? Of calcium. How do we find the number of moles of water? Very simply, we know that the whole compound is 5.76 and CaNO32 is 4 grams. That means how much is left for water? That means the mass of water is gonna be 5.76 minus 4, which is what? Which is 1.76. Now it's gonna be mass over molar mass. 1.76 over 18, that's 0.0978. So now that we have the two ratios, what can we do? We can do N of H2O over N of CaNO32. That's going to be what then? That's going to be 0.0978 over 0.0244. So that's going to be what? That's going to be 4 over 1. That means N next to 4, N of H2O is 4. That means this over here is 4. And the N of CaNO32 is what? Is 1. Very simply, this is how it works. We move on to question number 9. What does it say in question number 9? Describe the trend of the solubility of hydroxide and sulfates of group 2 elements. Very simply, what do you need to know? You need to know that as we go down the group, this is going down group 2. As we go down group 2, solubility of, first we start with hydroxide, solubility of hydroxides. It increases down the group, then sulfates, which are SO4 2-, it decreases down the group. That means if we are dealing with beryllium, magnesium, calcium, strontium, barium, if we have beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, or barium hydroxide, that means that barium hydroxide is gonna be what? Is gonna be the most soluble, and beryllium hydroxide is gonna be what? It's gonna be the least soluble. Now it's gonna be the complete opposite if we had what? If we had, just let me remove this because there's no beryllium sulfate. If we had sulfate, so instead of OH2 we removed it and we put what? And we put sulfate, so it would be MgSO4, CaSO4, SrSO4, and BaSO4. It would be the complete opposite, where Mg would be the most soluble and barium would be what? Would be the least soluble. Okay, very simply, that's it. Question number. What does it say? It says a sample of calcium carbonate, CaCO3, undergoes decomposition in the apparatus shown below. The gas collected is identified using a glowing spindlet, and the pH of the water mixture in the trough is recorded. What is the gas collected? We said when we decompose calcium carbonate, CaCO3, it will decompose into metal oxide in addition to carbon dioxide. So the gas collected is carbon dioxide, and carbon dioxide what will it do for a glowing splint? It will extinguish the flame. So, for a glowing splint, carbon dioxide will extinguish a flame, and it's gonna be the pH of the water mixture is gonna be a bit acidic, so around 6 pH. Why is that? Because we said as we go down the group, the solubility of hydroxides increases. So if we're dealing with magnesium, calcium, strontium, and barium, if we were to compare barium with calcium, definitely calcium would be less soluble of hydroxides, so it would not release as much into the water to cause it to be basic. So we will say that the water mixture in the trough is gonna be a bit acidic and will have a pH of 6. Now we go down to this one. Question 11, the last one. It says an anhydrous salt is heated strongly in a test tube. After a period of time, liberation of a brown gas is observed. To the remaining solid in the test tube, a small volume of dilute hydrochloric acid is added. The residue dissolves completely. To the solution obtained, a few drops of sulfuric acid are added, resulting in the formation of a white precipitate. The anhydrous salt turns the flame what? Scarlet red. Okay, so these are just the only two keywords. Scarlet red, we directly know that it's strontium, and brown gas, we directly know that it's NO3 because it will release what? It will release nitrogen dioxide. So what's the salt? It's SrNO3. Very easy, very simple. That's it for this video. I'm gonna do another one hopefully for the organic. Thank you guys for watching. I hope you enjoyed and have a wonderful